Today we are going to start a new chapter, only basics. So in this basics class we are going to learn list of formulas which will be helpful to solve problems from the chapter kinematics. Okay, so chapter kinematics. So basically, what is meant by kinematics? You should have some idea. What is meant by kinematics? Kinematics is a branch of physics, or simply to say kinematics is a branch of mechanics. So already I gave one introduction. Mechanics. In mechanics we have two branches. Number one, kinematics. Number two, dynamics. So these are the names we have up to 9th class, 10th class. But if you go to 11th class, names will change. Kinematics is also known as motion in a straight line. Dynamics is also known as motion in a plane. So there are different concepts. Motion in a plane will come, force and laws of motion will come, etc. So mainly force and laws of motion. What is the difference between kinematics and dynamics? Simple logic is there. In kinematics as well as dynamics, we will discuss regarding motion of a body. We will discuss regarding motion. But what is the major difference if you ask? In kinematics, you will not discuss about cause of motion. You will not discuss about cause of motion. Who applied force? How much force is applied? Who kicked the ball? With what force that ball is kicked? How we are applying force? Who is applying energy? Such type of things you will not learn in kinematics. But while coming to dynamics, here you will learn about cause of motion. You will learn about cause. With how much force we are kicking the ball, with what angle you are throwing the ball. So what is projectile motion? Such type of things. Okay, so these are the two differences. Today we are going to discuss concepts regarding kinematics and all the formulas we are going to learn, so which will be helpful in solving numerical problems from this chapter. So all types of problems we will see, which we are going to get in 9th, 10th, 11th, etc. Few MSET problems, few IIEEE problems, IIT problems also we are going to see, right? So I don't want to go into deep what is meant by rest, what is meant by motion, what is the speed, what is the definition for speed, what is the definition for velocity, acceleration, not required. Let us keep our mind only regarding IIT. So formulas required, like we will be telling na CDF, concepts, definitions, formula. First let us go with formula, then let us solve numerical problems. So first, list of formulas. Number one, first formula you are going to learn in kinematics, that is speed. Speed is equal to distance by time. Number two, velocity is equal to displacement by time. Okay, just a minute. I think in video. Speed is equal to distance by time. Number two, velocity is equal to displacement by time. Here one concept we should learn. Distance, displacements both will be same in one case. What is that case? Yes, please. Small d also you can take.
So distance and displacements are same in when the object is moving on straight line.
Very good. When object is going in straight line, distance and displacement's value will be same. See, in problems, 90% of the problem, same concept you are going to learn. Same concepts you are going to apply also. So whenever in question, if you observe body is traveling some distance of 20 meter, right, S is equal to instead of D is equal to, okay, right. So speed is equal to distance by time, velocity is equal to displacement by time. Distance and displacement's value will be same when body is going in straight line. Next, when D value is equal to S value, you have to understand one thing. Speed value and velocity value also should be equal, na? Why? Because you see, instead of D you substitute S, it becomes what? S by T. This also S by T, this is also S by T, this is also S by T, then both should be same, na? S is equal to V. So up to 9th class you will be learning distance is same, distance is D, displacement is S, small s, speed is capital S, velocity is V. But if you go to 11th class, either distance or displacement, both are represented with the same letter, that is S. Either speed or velocity, both are represented with the letter V. Remember that. So from now onwards, in any question, if we see distance, mention with S, displacement also mention with S, speed mention with V, velocity also mention with V. Any doubts till now? Right. Then we have another formula, acceleration. A is equal to velocity by time. Now for all these SI units we should remember. What is SI unit of speed? SI unit of displacement or distance is meter. SI unit for time is second. So meter per second is SI unit for speed. For velocity also SI unit meter per second only. For distance SI unit is meter. For displacement SI unit is meter. Displacement, distance, displacements both are same. Then acceleration SI unit is meter per second square. Meter per second square SI units. Now these are in P by Q form, na? Like meter per second. This P by Q form, how we can write it as PQ form?
Meter second.
So second you need to take it to numerator. So how we can mention? Meter S to the power of minus 1. Why? Because S is in denominator. What is the power of S? It is 1. When it is going to numerator, it becomes reciprocal. Now S unit of acceleration is meter per second square. If second square is going to numerator, it becomes what?
Power minus 2.
Yeah, very good. Meter second to the power of minus 2. This is also correct. This is also correct. Fine. Now, then we have another formula. These three are one set. Next. SAVG, average speed. Average speed is equal to total distance by total time taken. D1 plus D2 by T1 plus T2. T1 plus T2. Now there are few cases. Let us see. First case. Consider body is traveling some D1 distance in T1 time, D2 distance in T2 time, then calculate average velocity, like that he will ask. You can write d1 plus d2 by t1 plus t2. This is correct. Second situation I will tell. He will tell body travel from O to A with speed, let us mention with v. So O to A, it travelled with speed v1, and A to B, it travelled with speed v2, and it took t1, and here it took t2. Then find SAVG. How will you find?
V1 plus V2 by OA plus AB.
Why V1 plus V2? What is average speed का formula? Total distance by total time. But here they didn't give distances now. You should not change formula, right? How we can change? Are you getting the concept? Here in this example they gave distance values d1 d2. Here they gave time values t1 t2. Here you are going with the formula d1 plus d2 by t1 plus t2 by SAVG is equal to total distance travelled by the body upon total time taken by the body. Well and good that you wrote. But in the second situation they have given speed. Body has travelled O to A with this much speed and A to B with this much speed, V1, V2, time taken, then SAVG. We know formula SAVG is equal to total distance travelled by the body upon total time taken. Now no distances, what to do? Concept. So this is 11th class concept, you have to understand. So now you see, here what we should do? We know speed is equal to distance by time, right? Here total distance is required na? From this formula, distance is equal to speed? Speed into time. Okay, distance I said we can represent with S na? Speed you can represent with V, time T. Now instead of S you can keep V into T na? Are you getting the point? So instead of S1 what you can make? V1 T1. Instead of S2 V2 T2. Same formula you write. SAVG is equal to what is total distance? D1 plus D2 upon T1 plus T2. Now D1 is nothing but S1 only na? Distance. Don't get confused. S or D both are same. Distance, displacements both are same, both are going in straight line na? So that, okay, or okay, distance only you take. D1 is equal to, distance 1 is equal to speed into time. Instead of D1 what you can write? V1 T1. Instead of D2 what you can write? V2 T2. Like this we should convert. Are you getting the point? Okay, now another example. Consider a body starting from O going to A and it is covering distance D1. It is covering distance D1 and it is travelling with velocity V1, and from A to B it is covering distance D2 and it is moving with speed V2. Then find SAVG. So in first case we have distance time, in second case we have speed time, in third case we have distance and speed. Now I need average speed. How to go? Average speed. So what is the formula for average speed? D1 plus D2 by T1 plus T2. Do we have distance formula, distance values? Yes, we have. So we can mention D1 plus D2 upon. Do we have time values here? Do we have time value? No. Then what we can do? Again, we know speed is equal to distance by time. Now we need time. Send the time that side. T is equal to Distance by speed. Very good. Now T1 is equal to D1 by speed means what you can write? Very good. V1. T2 is equal to
D2 by 2.
now D1 plus D2 by D1 by V1 plus
D2 by 2 by 2.
V2, like that. So we have to convert everything. We can convert. Is it clear? Okay, next we have average velocity formula. VAVG is equal to total displacement by total time taken. This is also correct. That is also correct. We have another formula. VAVG is equal to initial velocity plus final velocity by 2. Why we are taking this? Average. In your subjects also, in your examinations also, you need to calculate your average marks. Sum of terms by number of terms. Here, how many types of velocities we have? 2 types. Initial velocity, final velocity. What is meant by initial velocity? Velocity at initial point. What is final velocity? Velocity at final point. How many velocities we have? 2. Sum of terms. Sum of initial and final by number of terms. 2. Like that you can take. Now we have, if you go to 11th class, we have one formula like VAVG is equal to delta S by delta T. Delta means, in chemistry delta means temperature. In mathematics and in physics delta means Govinda. Delta means small change. Okay, sometimes it will be like delta x by delta t also. That is also correct. Delta x by delta t. If they give delta s by delta t, you can write it as S2 minus S1 by T2 minus T1. If they give delta x by delta t, x2 minus x1 by T2 minus T1. Or simply to say xf minus xi by tf minus ti. What is f and what is I? F are final.
I is initial.
Very good. Like that you should take. Final minus initial. This we can take when we draw graphs. When we draw graph, for example, consider this is time. This is displacement. Okay, there is a graph like this. Example. Now you need to find velocity from this point to this point. What you can do? This is displacement na 0, 1 meter, 2 meter, 3 meter, 4 meter, 5, like that. This is time na 1 second, 2 second, 3 second, 4 second, 5 second. Now if you want to find velocity in this particular area, here you will draw like this, and here also you will take. So you will draw parallel lines or parallel to x-axis. Here you will drop parallel to y-axis. Now this is initial time na, this you can take it as ti. This is final time na, you take it as tf. This is initial speed displacement na, you take si. This is sf. Substitute or xi xf, like that. So in graphs you can use these formulas. 4 minus 2 by 4 minus 2, 2 by 2, that is equal to 1. Done. So like that. So these are the formulas, and one last formula is left regarding these. Then we will see another set of formula, equations of motion. Okay, last formula, AAVG, average acceleration. Average acceleration is equal to final velocity minus initial velocity upon time taken. So these are the set of formulas related to speed, velocity, acceleration, distance, displacements. Okay, copy this. We will see formulas related to equations of motion. Next, copy this. Now we will see another set of formulas from kinematics with three cases. First case, when body is going in straight line, like this, when body is going in straight line. Second case, when you throw any object or any ball vertically upwards, means if it is going like this, upwards. Next, a body which is falling freely from certain height, so from like this. Okay, so three cases we will see. Now, case 1, when body is going in straight line, there are three equations of motion. Number 1, V is equal to U plus AT. Number 2, S is equal to UT plus, very good, half AT square. Very good. V square minus U square is equal to 2AS. So these are three formulas when body is going in straight line on road. So in this, what is meant by V? Final velocity. U, initial velocity. A, acceleration. T, time. S for displacement or distance. U, initial velocity. T, time. 1 by 2, it's a numerical value, 1 by 2 or 0.5, etc. A for, T for, V for final velocity, U for initial velocity, 2 numerical value, A, S, displacement. So these are the terms and notations. Okay. Next, when body is projected vertically upwards, if you are projecting a body vertically upwards, then what are the changes you can see? How these formulas will change, that we will see. Okay, consider one example. Here there is a ground. Okay, you can see. Consider a ball which is situated here. Consider some body is there in my hand and I need to make this body to move up. I want to make this body to move up. If I hold like this, will it go up? No. You need to apply force. Very good. You should apply some force. If you are applying force, automatically it goes up. So from this concept, what we can understand is, if any body is situated on ground or on a certain height, you should apply some force on that body. So as soon as application of force, it will gain some velocity. So body is here na, at initial point, this is initial point. So as soon as applying force, it will gain some velocity. Velocity at initial point is known as initial velocity. So at this point there will be initial velocity. So if you want to make any body to go up, there should be some initial velocity for this. Without initial velocity, body cannot move. Clear? Without initial velocity, body cannot go up. Now body is going up, let us consider like this. So if you can observe practically, if you take a ball and if you throw up, first it will start with greater speed. It starts with greater speed. It will move certain distance. Its speed will reduce. Slowly it will go. Slowly. It will become slower when it is going up, and at certain point its speed becomes 0. So at this point its speed becomes 0. This is the point, initial point. This is the point, final point. So at final point, what is the value? 0. Initial point u is 0. There should be some value. It is not equal to 0. So we don't know. Let us mark it as u only. Initial velocity value is u. Final velocity value is 0. I said when body is going up, automatically speed is reduced, na? Why? Very good. Because of gravity, gravitational force. When body is going up, earth will pull down. Still it will be going up. Still it will be pulling down. As soon as how much it goes up, earth will be pulling it down. Right? That is because of gravitational force. So when body is going up, its acceleration will be in negative. Its acceleration means its speed will be negative because it is reducing now. Point by point it is reducing. So we'll mention A as minus G. G for not gravitational force. A for acceleration, G for acceleration due to gravity. You have to tell full. A for acceleration, G for acceleration due to gravity, and there is a value for G. G value is
9.8 meter per second.
very good. 9.8 meter per second square.
Approx 10.
Okay, so here I am. G value is 9.8 meter per second square. Approximately 10 and accurately 9.8. So where we will use A, where we will use G? When body is going straight line on road. So when it is going on, you will increase accelerator, na? When you increase accelerator, acceleration of the body will increase. So when body is going in straight line, we will call that one as acceleration. But when body is going upwards, we will call it as acceleration due to gravity. Either body is going up or falling down, we will call G. Clear? So when body is going up, A value is negative minus G. Then from this point to this point, it will take some time, na? So T value will be there. T is equal to T. Right. Now, you see, if it is like this, we will call distance. If it is like this,
Displacement.
Govinda. Guys, when I am sleeping down like this, you can take length. But when I am standing, what you can take? Height. So, when it is on x-axis, we can take it as distance. When it is like this, y-axis, you will take it as height. When it is down, depth. Under the ground, depth. Okay. Now, S value will be there, na? Some distance value.
Yes.
So when body is going up, yes, we have to take it as H, height. Now are you understanding?
Yes,
So once again, when body is going up, what are the changes you can observe? Number one, U value should be U value, not equal to 0. If it is equal to 0, body will not go up. It cannot move, it cannot go up. Right? So definitely U value should be U. When it is reaching at final point, it is 0. So that only it falls down. Or else it will be going on like rocket.
When we falls down, A becomes positive.
Then we will take. That is second case. Now still we are in second case. That is third case. Case 1 is this. Body going in straight line. Case 2. Body is going horizontally upwards. Upward. So V value will be 0. Then acceleration value is minus G. Time value is T. S value, displacement or distance value is height. Now substitute everything here.
0 equal to
Very good. Tell me.
0 equal to
0 equal to U plus minus G into T. Very good.
minus GT.
Is equal to U plus into minus GT. Minus gt, send that side.
GT equals to U.
Very good. gt is equal to u, or you can write it as u is equal to gt. So here this is the important formula. After solving, this is the important formula. Right? Are you getting the point?
Yes, sir.
Just you are substituting this and you are deriving this.
What T means T equal to U by G.
So they will ask, if you are taking a body and g value is 9.8, it has taken 10 seconds to reach, what is its initial velocity?
9.8 into 10.
9.8 into 10, that you can take, that is initial velocity. Simple. Okay, now substitute these again here. Yes, h is equal to u t plus half minus g t square. H is equal to ut plus into minus minus 1 by 2.
GT square.
That's it. So if you want to calculate how much height it has reached or how much distance it traveled to reach that height, you can use this formula. Now substitute.
0 square minus
Very good. 0 square minus
U square.
u square is equal to 2 into minus g into h.
Yes, sir.
Minus u square is equal to minus 2gh. Minus minus gets cancelled. U square is equal to
U
2gh.
equal to root 2GH.
Very good. U is equal to root of 2gh. Okay, from this we can have another derivation also. T value.
U by G.
T. T is equal to,
U by G.
very good, u by g. Means if you have initial velocity and if you know g value, you can calculate time taken to reach that maximum height. So is this clear?
Yes, sir.
If you have any doubts, you can ask. Any doubts? Fine. Next, third case, when body is falling down. Okay. This is case 2. Now case 3. Body has to fall down. If body wants to fall down, for example, here I have a body
So
cap which is at certain height from the ground level. Right, now I am holding like this. Now I want to make this body to fall down. Do I need to apply force?
no, sir.
No, just leave. If you leave, automatically it falls down. So are you giving any force for that?
No, sir.
Is there any initial velocity for that?
No, sir.
No. So when body is falling down, its initial velocity is 0.
Final velocity increases.
And you see, when body is falling down, you can observe slowly, gradually its speed will increase.
Yes, sir.
Speed will increase and it comes down with lots of speed.
So first one.
So from this what we can tell, when body is falling down, acceleration will be positive.
Positive G. Positive G.
Positive g.
G.
So that only when you are throwing cap, after touching the ground, we are getting sound.
Yes, sir.
When you take a ball and if you leave, it will bounce. Why? Because it is touching the ground with acceleration. It is touching the ground with velocity. Right? So when it is touching the ground, will be there velocity?
No, sir.
Yes.
V.
There will be velocity, that is v. We don't know, so that only v value we are taking it as v. And from this height to ground to travel, it will take some time now.
Yes, sir.
T value is t. Very good. T is t, same. Then from here to here, it will travel some distance now. What is that? H. From height only it is coming down now. So, no. From ground level if you are going down, that is depth. From ground level if you are going down, that is depth. Are you getting the point? So when body is falling down, u value is 0, v value is v. Why u is 0? Because its initial velocity is 0, no need to apply force. When it is touching the ground, it is making some sound. If you take glass and if you throw, it will break. If you take ball and if you throw, it will bounce. It will, if we take some metal and if you throw, it will make some sound. Why? Because it is touching the ground with velocity. So V is equal to V. And it will take some time. T is T. It is traveling for some distance. There is a distance. S is equal to H. Now let us substitute everything.
V is equal to 0 plus GT. V is equal to.
Shall I rub this?
Yes, sir.
Or else let us substitute and rub. Case 3.
V is equal to.
V means
So V
is equal to 0 plus G na? Plus G into T. V is equal to 0 is 0 plus into plus G into T. So this is the formula. V is equal to G into T. Now from this we can derive T also na? T is equal to V by G. Very good. Now here S means H is equal to 0 into T plus half plus G.
T square.
Very good, T square. H is equal to 0 into anything 0 half plus into plus only G T square. Done. Now V square means V square minus 0 square is equal to 2 into plus G into H. V square is equal to 2GH. V is equal to root of 2GH. Did you get it? So formulas which are in the box are important, which we are going to use for solving numerical problems. So from this we can have another concept, that is, they want to one concept with which I'll end this class, just 2 minutes. You see, when body is going up and it is coming down, one concept I'll tell you. With what velocity body is starting its journey, with the same velocity body will reach down. Means if you are taking some object and if you are throwing it, with what velocity you are throwing, with the same velocity it will touch your hand. Proof is this. What is U value?
GT.
What is V value? See here, both are same na? U value is GT. V value is GT. From this what we can conclude? U is equal to V. You can conclude. And I'll tell you. From ground to this height, how much time it will take? Same time it will take to reach ground from height. How much time it will take to reach that height? Same time it will take to reach the ground from the height. You see, what is T value here? U by G. What is T value here? V by G. U is equal to V na? So U by G, V by G both are same na? So from this what we can tell? T is equal to T. Now there is one expression. Time taken to reach height, we will call it as TA, stands for time of ascent. Time of ascent. And time taken to reach the ground is known as time of descent. Time of ascent and time of descent both are same. Time taken to reach height is equal to time taken to reach ground, and time of ascent plus time of descent is equal to time of flight. Time of flight. Time of flight means time taken to be in air. Time taken by the body to remain in air. How much time it is remain in air? From this point to this point, it is in air only, na? That is time of flight. Time of ascent plus time of descent is equal to time of flight. What is time of ascent? That's what is TA? Time taken to reach height from the ground. Maximum height from the ground. What is TD? Time taken to reach ground from height. What is time of flight? Total time taken by the body to remain in air. Okay, right. Next, same conclusion you can tell. U is equal to V. From this, what is U value? What is V value? From this we can tell U value is V. Both are same. Okay, right. So U square is equal to 2GH. V square is also 2GH. So these are the formulas you need to remember and learn so that you can solve any numerical problem in your 9th, 10th and 11th. Okay, right. Copy this and that's it in this chapter, and copy all these formulas which I told earlier regarding speed, velocity, acceleration, distance, displacement. This is regarding equations of motion of 3 cases. Case 1, body is going in straight line. When body is going in straight line, V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS. When body is falling, no. Second case, when body is going up, U is equal to GT, H is equal to UT minus half GT square, U square is equal to 2GH, or U is equal to root of 2GH. Case 3, when body is falling freely, V is equal to GT, H is equal to half GT square, V square is equal to 2GH, or V is equal to root of 2GH. So up to 11th class, any numerical problem we can solve it. We will see these problems also. We will see for every model. I will give one problem from next class. Okay, we will solve it. Copy it. That's it in this class. We will meet in next class.